We'll be starting very shortly the zero carbon future panel. We are also welcoming now people streaming from Canada and from our showroom in Canada, and also other people joining perhaps from their home offices or from their offices. So again, as last time, we are taking questions from anyone via the Slido app or on the Slido website, sli.do. And the code for the event is 537970. So that's Slido, sli.do, and the code 537970. So we'll just start off with introducing the panel. Could you perhaps start us off, Michael?
Right, hello everyone. My name is Michael Trousdale, and I work at WSP in the Building Services practice. And my role there is to effectively lead on sustainability from a design perspective and also on delivery of our smart building consulting. And I think it's really interesting where those two things overlap, in particular on the operation of buildings, where sustainability and good effectively control strategies come together.
Next, good afternoon, everybody, and I'm Dr. Zainab Dangana, and I work for the WAITS Group, and I lead and manage the WAITS Sustainable Technology Services, which is an initiative that was developed to support innovative suppliers accelerate their route to market, and also help our customers and project teams to accelerate their transition to net zero. So we play the role of a facilitator and a catalyst between the supply side and the demand side, and helping businesses build back better and also accelerating transition to net zero.
Afternoon, my name is Chris Lister. I'm the value stream lead for a company called Façade. We are a global specialist in isolation, and in my particular role, it's to do with the thermal isolation, so structural thermal breaks. My background is in architecture, but latterly I am the non-academic supervisor for several PhDs with Salford University.
Toby?
I'm Toby Cambray. I'm a founder director at Greengage Building Energy Consultants. We're M&E engineers, building physics consultants. I lead the building physics team. And we do a lot of passive house design, thermal bridge analysis, all sorts of different kinds of modeling that you can do on buildings. We also like to measure stuff. I'm also recently started a PhD at UCL, looking at moisture in historic buildings.
Thanks, and my name is Nick Orton. Been at SAP 15.5 years and work with clients at early stage, normally reading stage 2, 3, 4. And more recently been doing a lot of research and writing some white papers and so on alchemy, sustainability, and carbon, which is obviously very topical right now. So to kick off the discussion, and perhaps, Chris, I'll ask you this one. Start off with net zero carbon future. There's many different countries talk about 2030. Might seem a long way away, but what action do you think needs to be taken now?
I think the key actions are, in the first instance, to understand that it's not going to go away. As you see from all the discussions in COP26, the framing of this is that this is the 1 minute to midnight, that this is the last chance saloon, and that we haven't really been taking it seriously up until now. There's always something else getting in the way. There's always something else better to do. And that now we really need to start thinking about it. 2030 is not that far away. 2050, whilst it seems a long away, is not, in terms of the global situation of the climate. So I think from my point of view, it is a wake-up call. It's an understanding for anyone and everyone who has something in the game here, to start really thinking about what they can do and what they can do to contribute.
Michael, what's your thoughts on that?
So I think a key point looking at that more global scale is is the electrification agenda. And that happens in all sorts of ways, transport and in buildings. I'd say here in the UK, we're getting particularly excited about using heat pumps. But while that's the high-level direction of travel, there are lots of pitfalls and challenges about making that work. And the key things, zooming right back into why we're here today, thinking about, say, resi buildings, tall buildings especially, electrification in that context is really challenging. And you've got to be doing great facades. You've got to be working on the thermal bridging. All of those things play into it being actually practical and viable. Otherwise, the heat pump on the roof is just far too big. How are you going to fit it in? So yeah, electrification as a goal, but then practical, actionable steps in terms of design.
So what are your thoughts?
Yeah, I think we're in an industry that is making a huge impact on climate change, and the buildings contribute to about 50% of carbon emissions. But the good thing is that we're also in the best position to mitigate those impacts. And the better news is that we've got those sustainable technologies out there that would help us. And research says that 95% of market-ready products are never considered. And if we are to achieve the net zero target and to address the challenges of climate change, it's very important that we nurture and support those technologies that are out there. And the problem we have is that everybody's risk averse. They don't want to be the first person. So we need to have a strategy in place. We should be able to collaborate, work together. There's a big piece around educating people, raising awareness. And this is just not people in the construction industry, but end users, home owners, the users in official, in commercial buildings and all that. So there's a lot of education that goes into it so that people can understand the benefit of the buildings being more sustainable and seeing the tangible results, whether it's been in the savings it can provide. So for example, there might be a smart toilet, but equating that to something that they could relate with. So maybe the equivalent of 2 Olympic-sized pools. So there's a bit of awareness and education, and then informing them about where they can find information, because a lot of people, stakeholders, project teams, do not know where the products or solutions are. So they need a bit of a guidance. And lastly, I think we need the finance and the incentives to make that happen, because sustainable technologies definitely cost more. And that has been the barrier for a lot of clients and project teams that are interested in the sustainable products, but they don't have that initial upfront cost. So there are a few different things that we probably need to do to sort of make that happen.
So what's your thoughts on the how far away it is?
Well, it's basically 8 years to 2030. We're coming to towards the end of 2021, and so that time will go. Is there. I mean, the construction industry is notorious for moving slowly. Over the last decades that we've known about this issue, very little, relatively speaking, has happened compared to where we need to get to. So we've really got to get a move on. And what it comes down to really is we've got to stop burning stuff as a society. It's a bit trite, I know, but that's how simple it is. We've got to stop taking stuff out of the ground and burning it. We've got to stop, frankly, burning trees. That doesn't help either, in whatever form that is. And just to pick up on what Michael was saying about electrification, that seems to be the direction of travel on everything in the UK at the moment, and that makes a lot of sense. Absolutely agree about the point about the facades, but it's not just about the size of the heat pump you've got to put on the roof. If you do the numbers, then we've got the majority of the energy that we use to heat our buildings and indirectly via electricity to cool them as well is by gas, and we can't just transfer all that energy demand from the gas system onto electricity system. We can do a lot, but the cost of that is just astronomical when if you want to do that on renewables, which are somewhat intermittent. We need storage and a lot more infrastructure. But the good news is that we can mitigate those costs by building more efficiently and using a lot less in our buildings, which is why the efficiency in those brilliant facades are so important.
Interestingly, 2 years ago this week, I was at a conference where we were talking about tall buildings, and it was quite interesting that one of the presenters was talking about the leading of the tall buildings in London. And they took all the buildings being built over the last 20 years and looked at, and the average was a 10-year span from design to the actual completion of projects. So the point they were making then was, we've got 10 years to hit a 10-year target if we act now. We're 2 years later now, further down that line, and it's an interesting comparison. But we with carbon and with the environment, it's quite easy to look ahead continually rather than what the practical steps are now. And hopefully we can get a bit of a balance as a panel to actually get some of those practical tips people can do things with now. But one of the questions, looking further ahead into the future again, COP26, it wouldn't be, we have to speak about it today because it's going on right now and it's quite a major thing in the news and so on. But what do you think the likely impact is in practical terms on the way we as a construction industry work in the future? What, Dr. Sadie, perhaps if you start off down.
I think the good thing is that a lot of industries have already made a start before the COP26 because the UK government sort of declared the net zero target in 2019. And following that, when I last checked it, over 70% of local authorities have declared a climate emergency. And that's filtering down on all industries. And for the construction industry, architectural firms have now got to follow the RIBA sort of guidelines, and there is support there similarly for RICS. So we are going to be pushed from that angle. But what I'm also saying is that it is becoming a license to trade now. So if you are not investing or doing something to reduce the impacts of climate change, you could be out of business. And I'm seeing a lot of companies, not only the construction industry, but all industries saying what they're doing on that agenda. So I think it's going to become more important now with the COP26, and hopefully people would start acting now, and it wouldn't be a green blink, but it would become more practical, hopefully.
Yeah. Michael, any thoughts there?
So I'm I'm generally skeptical about the link from politics into practicality. And so I think it's really important to say, the movements that are already underway, all the activities that are more local, are where we can create the link between the strategy level policies of 2 degrees, 1.5 degrees, and actually action happening. But it draw attention to something else that's happening at that sort of global scale, and that's influence of the financial markets playing into what people think in terms of the sustainability of buildings. And really interesting, in the FT just a couple of months ago, Jefferies, the American bank, had down rating effectively the share price predictions for a couple of, I won't name the developers, but a couple of the developers here in the UK, because they just set off one of their junior analysts looking through all the EPC ratings of their building stock and saying, by 2025, they're going to have to spend hundreds of millions to renovate these buildings. We're down rating their stock price. Now, the CEOs of those companies really care about that sort of feedback. So I think there's a potential for more transparency on understanding where buildings are. So all of these rating systems, we can talk about neighbours, for instance, on an office building, the particular one that's coming in from Australia. That transparency means that you can have a grad in a bank borrowing away and making public statements about the performance of these buildings. You can't hide anymore. So that's a sort of global scale thing that's happening, and I think could be really impactful.
So picking up the point you've made there, we've had a question as to are the current government schemes which are aimed at decarbonisation for private and social housing, are they hurting or helping the industry? Chris, if you perhaps pick up on that point.
I think my view, slightly different view in terms of whether I think the COP26 and policies and schemes work. I believe that they're the flag that people see, and I think there is an element of stick rather than carrot in the legislation that makes people do stuff. So I think these schemes and ones that are put forward by government and have some legislative clout are a positive thing. That said, I'm picking up on the banking analogy. A lot of what we have seen in building specifications coming through, and it relates as much to the existing building stock as new, is that people, insurers, want to see their buildings future-proof, and they are going beyond the regulations. So even though in some aspects regulations don't call currently for as high a level of performance in the building as is potentially going to be needed, the people who are putting the money up behind these buildings have already figured out that they are going to have to make sure that these things are going to last for a lot longer than 2030. And so therefore we are seeing those people driving some of the specifications behind the buildings, particularly when it comes to thermal performance, which is an area that Façade are particularly involved in.
It's interesting points. Toby, have you got any thoughts on this?
There's a lot to unpack there, isn't there? So just to kind of pick up on the EPC side of things, that's really interesting. I wasn't aware of that sort of financial pressure that was coming to bear. So that's in one way quite exciting that's kind of happening. But on the other hand, a massive problem with EPCs is they don't do what they claim to in terms of predicting energy performance. There's a brilliant graph which I could show it to you now. Basically, it shows that there's only a very weak correlation between EPC grade and the in-use energy consumption. Certainly for dwellings, for non-dwellings, we have DECs, which are hopefully a bit more robust. But this is resi build, so is that the right kind of tool to use to drive improved performance in terms of carbon? And I think my take on that would be no. So there's that kind of issue that's kind of really deeply embedded in the kind of cultural thinking about the way we regulate the energy performance of buildings, that I think needs to be looked at very carefully. I've forgotten the other thing I was going to say. So legislation, I think, in terms of COP26, really what what we're going to see as an industry as a result of any government pledges that hopefully will be forthcoming, will be in the form of regulation and legislation. And we've been talking about this for a very long time. There's the Part L consultation a couple of years back. I can't remember if we've had a response from that yet. There's certainly no meaningful sort of change happening yet. But I think all anyone can really ask for is a level playing field, and that's kind of what I think I'd argue for when we're designing and setting up these regulations and legislation. Let's just agree on where we're kind of going with that, and make sure it's all kind of fair and everyone's playing to the same rule book.
Yeah, so there's a lot of smoke and mirrors, isn't there, and in some aspects, whether intentional or not. But one of the questions we've got here is what are the key drivers with an external envelope becoming carbon neutral or working to a carbon deficit? Chris, this probably suits you quite well, this question.
I mean, from a company point of view, we are looking to develop our materials to the greatest degree that we can. So we are a manufacturer of a building element. We have control over that building element. And so therefore our drive is to make that as good as we can. It then goes to form part of a building envelope, and hopefully alongside all those other components, they start to reduce the carbon load of those elements. But that does come down to individuals, and it does come down to people having the either the forced political will to do it or the financial will to develop those products. and this is where this carrot and stick approach comes. Just on the legislative requirements of Document L, Document L is a set of broad guidelines. It's a set of instructions that you can follow if you want. They are not enforceable under law. They are a set of guidelines, and so therefore maybe there needs to be more in the way of stick in that approach. So this is, we will do, because of us being a company that we are, the development that we need to do to get a better product and to lose that embodied carbon. But whether or not everyone else will do it is another question.
A point I'd add on that, there's a Part Z hopefully coming up, which is the embodied carbon. And I think particularly thinking about facade design, there's this trade-off between the energy performance, the sort of Part L picture looking in the legislation, or the embodied. And some analysis we've run on particular settings, the triple glazing energy saving that you get in some cases can weigh against the embodied carbon, and a double glazing element with less embodied carbon with certain energy use profiles and occupancy profiles, it could actually over the full lifetime be okay in some cases. So very interested in the embodied carbon aspect being added in, which is it's happening. People are thinking about it now, which is great.
It's a really good point you make, and it's the same with solar panels or electric cars. If you measured them by embodied carbon only, wouldn't stack up with it. So it is taking both considerations of use and the embodied.
We'll just make a correction on that. They do stack up still, but it takes longer. And so so the sort of the view of it being a really quick win isn't necessarily true with those. But the examples we've used, they do still stack up.
Yeah, I think having sort of the right policies and legislation in place could help drive it. And I had a point in my head and it just slipped away. But the embodied carbon, what we're beginning to see more and more within our project teams is that they don't only look at the product helping with BREEAM or LEEDs or other things, but they're going into the detail of the product. And that's where they start looking at the embodied carbon. Where was it manufactured? Has it used the principles of the circular economy? So we're seeing sort of project teams going into the detail of the product, and we did used to see that 2 years ago. So I think we're very concerned about how products are manufactured and delivered to the site. So not only when they come to the site, but what's the process before that?
Yeah, so stages A1 to A5.
Yes.
Yeah. So from a particular facade point of view, how would Waits approach that, or what are some of the key takeaways you could give to somebody here today who might be designing a facade?
From where I sit, I help identify sustainable products. So as a minimum, before we can consider a product, we want it to be market ready, at least to a point that at least we can trial it or pilot it, because we know there needs to be a first out there, and that's the support that we are doing. But we would like to make sure that it's compliant with the building regulations. With the facade, the key problem I see is more around combustion and the fire issues, which has been really, really sort of high on the agenda for a lot of people. So they focus more on that, and it's more a risk to them. So they are concerned. So as far as it can comply with the basic, legislation, and they're happy, but I think it's also going a step further, because with the Grenfell, it was evidence that things still failed. So I think everybody is now being careful.
Yeah, absolutely. Toby, I know we've done some testing with you on some apartment blocks not very far from here. But tell us what are the key principles to look for if you're designing an external envelope?
So, I mean, there's actually a step sort of before that that's sort of covered quite nicely within the sort of passive house approach, that is not handled well actually by the way that SAP and Part L is set up. This doesn't really apply to the sort of higher rise stuff that we're talking about today, but the name of the game there is form factor. So how much exposed surface area have you got through which you're kind of losing heat for every kind of useful bit of floor area in your flat or your house. And SAP effectively, because of the notional building, the way that's kind of set up, it sort of ignores that. But if you look at things on a kind of an energy per square meter basis, then it's super important. And a flat of 100 square meters or whatever is much more efficient than a detached house of the same useful floor area. And it's all about that kind of exposed area. The flats are kind of sharing their heat loss area sort of up and down and sideways. So there's that bit. I won't sort of go on about that anymore. Once you sort of got that form sort of fixed, then it's really about lots of insulation and trying to make it as continuous as possible in sort of very simple terms. And that can be quite tricky, actually. Particularly on high-rise stuff, and you can get into sort of counterintuitive loops, particularly with this form factor thing in there as well. So on some of the passive house high-rise stuff that has been looked at, a project team that I work with quite often end up actually going for a slightly thinner layer of insulation to get, and this was a passive house certified building, to achieve that thermal performance, because it meant that they could get away with a lot less in terms of thermal bridging. They didn't have to have so much steel work to hold up the brickwork. And the whole thing could be a lot simpler and less costly. So I don't know. There's an anecdote. It's complicated.
So certainly from a balcony point of view, some of those key principles, and for instance, designing out one balcony anchor makes a big difference to how much energy you can lose through that particular thermal break. But likewise, you've actually designed out the embodied carbon of the actual anchor in the first place. And fortunately, from a balcony point of view, actually a lot of the things you can do to improve carbon actually reduce cost. We're quite used to talking about sustainability being an increasing cost, and in many cases it is. But in terms of one of the questions we've got here is around the actual challenges of actually delivering improved carbon buildings. We'll start us off here, Michael.
Well, I'll continue on the thermal bridging question. I think it's just so important. The analogy of, say, a bucket being full of water, and if that's the heat inside your building, these thermal bridges are effectively holes, and the heat literally just jets out. A steel connection will be letting heat through 500 times faster than through the insulation over obviously a much smaller area. But I really feel like it's not talked about enough, not thought about enough as a key principle of design. Exactly as we were saying, we can't just sort of fix this just with products after the fact. I know Façade have some excellent products that you can use when you absolutely need to bridge. You can't not bridge forever, but designing first to avoid these thermal bridges has just got to be critical. To me, it really is a high priority item.
And it's not handled, again, I'm being pretty down on SAT and Part L today, but thermal bridging is not very well covered off.
No.
Within those regulations. I mean, a lot of the work we've done looking at thermal bridges is actually more driven by Part C, and basically looking at minimum internal surface temperatures. And
the condensation risk.
The building control officers pulled it up and said, I'm worried about the internal surface temperature. We've done the calculations and said, it's a bit dodgy, but also, did you know that you're losing an awful lot of heat through that junction because the SAP assessor has just put in standard assumptions, and no one's really thought about it.
Yeah, and building control obviously come round to do spot checks, and they're at that juncture right at the end, there's really little that you can do as well. And so having it right up the agenda for clients, designers, so that it can be thought about when there's a chance of doing something is really critical.
It's interesting. The passive house standard is one of its guiding principles is the removal of thermal bridges. As a seller of things that sort thermal bridges out, when we're able to cut out all those thermal bridges, our commercial guys don't particularly like it, but with my architectural hat on, that is the guiding principle. It's to avoid, to start off with it right at the beginning and say, right, if I don't have to have that piece of steel coming through my wall, that's what I should do. But it's also interesting that once you've understood that I am really going to have something to hold that balcony up because I can't float it in midair, then doing what you can to mitigate that with materials that are suitable to hold up the balcony and also stop the thermal bridging is the way to go. Just with Passive House on mind and also our Canadian audience on mind, we've done a lot of work in Vancouver, and we've seen one of the things there is the pickup of the Passive House standard, to the extent that since 2017 in Vancouver alone, they've built and designed and built more Passive House buildings than the whole of the UK since they first introduced it. So it is possible, once there is a will for people to do the right thing and to make sure that their buildings are sufficiently insulated.
Sorry, just to jump into this. So Vancouver are boxing really clever on this as well at a policy level, to go back to this kind of thing about how do we, what's coming out of COP26. But I believe they are permitting developments and additional floor area on dense urban development, so you can go up a few more stories effectively if you go for Passive House certification and achieve it, obviously. So they're providing the carrot as well as the stick there. So
it's a really interesting point, but there's many provinces, and Quebec are the first one to actually introduce it as a mandatory requirement. But actually having a thermal bridge is something which many balconies over there don't have. They cast a concrete slab all the way out. You can imagine heat loss in a climate which is far more extreme than the UK as well. But these are some of these things are not difficult. There's lots of knowledge around Europe and beyond as to thermally isolating them, and certainly these aren't new challenges, but perhaps the extremity of things are. But sorry, were you wanting to say something?
Yeah, I wanted to sort of say it from a slightly different angle, and not the thermal bridging part, but because the question was around the challenges, and I think I'm going to talk more about the systematic challenges that are out there. There's a lack of collaboration between all the stakeholders. Everyone seems to work on their own. The contractors are not involved at the early stages, and by the time the project gets to them, it's too late to sort of make any decisions because everything has been specified. And then the building then gets passed on to the end users, who are then responsible for managing the building. So I think collaboration is missing there, and that's one of the themes of the COP26, about different stakeholders working together and getting involved right at the start. And I think the RIBA plan of work, the revised version, tries to bring all the stakeholders right from the beginning, and sustainability is at the heart of it now. And the other thing, obviously, is yes, these sustainable buildings are going to cost more. We know it's got an increase of about 3 to 8%. So this needs to be factored in right from the beginning. And again, another theme of the COP is finance. So hopefully those two things would help. And the other two themes of the COP26 is mitigation and adaptation, which is where the technologies and the solutions are. So I think we need to be, focusing on those things, and hopefully after that COP26, maybe we'd have a proper process that could help us with the products and the solutions and the collaboration needed and the finance to achieve the net zero target.
So this collaboration is certainly a theme which has followed the whole day, from fire to competency, and we'll talk about it again, but it is important at early stage, isn't it? Because that's the stage when key decisions can be made and factored for, as you say. Moving on to a bit more about the challenges. What are the key challenges faced during occupancy, and how they relate to carbon? Quite a generic question there, but Toby, start us off on this one.
what are the key challenges for occupancy? Well, you'd hope if the building's been designed and built properly, then there hopefully wouldn't be too many. I think just to kind of one thing that pops into my head is that I think we need to put a bit more trust in the occupants sometimes. So a lot of the times design teams are worried about putting in these, complicated window opening systems or something like that. And, it's like, sometimes I feel like, well, people, know how to open windows, or maybe we should empower them to actually do that. For example, that's just kind of one little sort of thing, really, rather than in one building I went to, there's a little thing on the wall that it says in kind of Gothic font, you may open the windows or do not open the windows. And it's like, well, can we not just kind of trust people to sort of do that and make those decisions for themselves? I'll have to think about that and make a lot more.
I'd say once you're operating buildings, a key high-level challenge that we've got here, particularly in the UK, but many countries around the world, is the fact that the way we design for energy performance is so theoretical. There's this huge energy performance gap that we keep talking about. So having there's been a consultation the government's running recently, submissions are now closed around the design for performance sort of framework that, say, office buildings in Australia, they're all designed against the neighbours rating, which is energy bills divided by floor area. You can't escape from that. Very simple. And so I'd like to see for operators of buildings or owners, if you're sitting in your own building, that there would be the comfort that everyone who's come before actually had to think and behave to make it easy when you're operating. Because right now we don't. We sort of hand the buildings over. The way we've been designing doesn't relate to the way they're operating.
Interestingly, there's a question which has come in about neighbours, which is neighbours likely to impact office design? Not particularly as relevant to the theme of today, but you might want to be able to answer that briefly.
Well, I am hopeful that it will. It's been very useful in Australia to broaden the comment, I suppose, into residential. I think it would be fantastic if the government did here legislate for design for performance inspired by, say, how neighbours has influenced the office market in Australia. So I think that's all I'd say.
I mean, occupancy is always it's an interesting one. Having worked on pilot schemes for upgrading the existing housing stock in the UK with external wall insulation, a lot of the pilots were carried out. The fabric was upgraded, and everyone went, "Great, that's warmer. I can just take another layer off." And the reality was that people will be people. You might think that you're about to reduce the amount of energy because you've super insulated something, but some will go, "It's a bit hot," and open the windows. There is a human element to everything that we do, and there is a human element to the buy-in for whether or not, having looked at my smart meter, I will turn it down, or whether, having looked at my smart meter, I will say, right, I'll save that. I'll use that money I've saved by flying on a holiday to somewhere and using more carbon. So, and again, coming back to the broader challenges of a global community, those are some of the challenges. People's mindset, energy, in some parts of the world is an absolute privilege, and in other parts of the world it is taken for granted. And that's one of the areas that's got to change.
So one of the last panelists was admitting to some socialism, or sort of flirting with that, I think. But I mean, there's a fundamental issue with capitalism, which it doesn't really take into account properly all the external cost of energy, and particularly in carbon. Are carbon taxes the answer to that? I'm not sure. But yeah, there's a real kind of fundamental issue there with that the real cost of energy is not reflected in what we pay for it.
One of the other questions we've got is, what is the role of recycling in carbon? Sadie, would you like to start off onto that?
Yes, so that's around the circular economy, where we look at a product and we're trying to reduce the amount of materials or products that go back to waste. So when a product, let's take a window, comes to its end of life, is there anything that we could do to sort of put it back into the life cycle? So could we put it back in the remanufacturing process? Could we use the glass panes in the way they are back, or could we sort of add another layer to it and put it back? So that's what the circular economy is about, reducing waste and going in that loop. And there's a lot around that in terms of building services. So when we look at products, we're like, what's going to happen at its end of life? Could it be recycled, refurbished, refabricated, and put back? And that's what the circular economy is about.
There's an opportunity to look at the sort of pricing and service models that companies are considering. There's been, I understand there's some early conversations about having Façade as a service. Right now you can get, occupancy sensing as a service, and they'll rent you the little sensor. That's not doing a huge amount for embodied carbon, because there's obviously the little sensors are tiny. But if a Façade manufacturer was willing to take on the responsibility of replacing cladding after 15 years and continuing to provide a particular performance, and committing to the recycling process as part of a sort of, you get paid every year instead of a sort of one-off capex investment in the Façade. So hopefully there'll be financial mechanisms like that to incentivize exactly what you're describing there on the technical side.
So I think once things get a value, then it starts to make a difference. So things that can be recycled and have a value, aluminium, for example, there is a world market in recycled aluminium, and 70% of all the aluminium that's used new it isn't mined from bauxite. One of the concepts, certainly, this is based on essentially a premise that 50% of what we can do to get to our 2050 target is inefficiency, and the other 50% has got to be stuff we've never done before, and it needs to be new thinking, and it needs to be new ways and new directions. One of those aspects is urban mining, is the ability to take something, a building, and essentially take all the bits out of it. So it's this idea that you have an intrinsic value to that piece of glass, and you will make sure that at the front end of whilst we're doing it with existing building stock, as an architect, you're designing your building to be dismantled at the end of its life. And maybe some of those bits won't last 50 years or 100 years. They will generally only last 15. And so they've got to be designed to come out and be reused. Otherwise, it goes to landfill. And therefore, it's of absolute no use. So these are, even in a short space of time to 2050, mindsets that need to change in order for us to get to where we need to be.
So we've talked there about the recycling end of life. We certainly find it quite early on. Sometimes the only thing people are focusing on from a carbon point of view is the percentage of recycled material into a product. It does have to be taken in consideration because, for instance, one example is you can manufacture a balcony using 3mm components and a very high recycled content. However, you can have a product which is slightly lower on recycled content as a percentage, but because of the grade of aluminium, you can actually use it as a 2mm, which designs out a lot more embodied carbon. So these things need to be taken in consideration, not just in isolation, but as we've been talking about, getting that whole 360 view about things. But I'd like to put it out to the audience. Has anyone else got a question which they may not have put on Slido? No? Okay, we'll move on. One of the questions which has come on through from Slido is, what is the role of DFMA, Design for Manufacturing Assembly, in reducing the environmental impact of construction? Start us off there, Michael.
Yeah, so within the building services and RISI, there's already a lot of focus actually on the utility covered being all standardised, and I think the time to construct and the efficiencies that you can achieve by doing off-site manufacturing is really important. And I think that's the obvious point that we've started with on building services. That sort of utility covered component, but you can see central plant also again being lifted on, especially roof-based plant being lifted on with a lot of the work going into some off-site manufacturing. So yeah, I think it's absolutely really important to drive down the material efficiency and also improve the performance. Something that hasn't come up actually yet is air tightness, which is a big thing, narrowing in on the facades. And so having those sort of tolerances and the accuracy on the way that all the facade components come together is critical for achieving the air tightness targets. And the more of the facade build that's done in that sort of clinical setting in the factories, the more likely you're going to get those air tightness targets down as well.
One of my hats is as a vice chair of the British Construction Steel Association, which is pretty much all about building the stuff off site. It's steel frames that are managed, put together, having come as a kit of parts. Those sort of elements, albeit that steel has a lot of embodied energy in it, but the principle behind it is correct. And once you get to the stage where you can start to reduce the amount of energy, whether that's in carbon capture or whether that's with arc furnaces, the will is there to drive it that way. And it's a global scale. It's a global scale. Steel is one of two things that you build structures out of, if you think about it, unless you're building timber as well. But we're still at the very, very start of it. But at least there is a will to start doing things. The conversations about how do you decarbonize steel would not have happened 10 years ago, but they are definitely happening now.
Your thoughts, Toby?
So I think as important as designing for assembly is designing for disassembly. So linking back to the last kind of question, can we think more carefully about how we take things apart at the end of life, or indeed for maintenance and things throughout their life. If you need to clean behind a bit that's needs to be taken off, it's all part of that sort of idea of prolonging the life and sort of reducing and reusing before we recycle. So I think that's something that's I'd like to see more of.
So a really valid point. DFMA may make it easier if it's an attachment or something to a building, but it may make it more difficult if it's an integral component which has been built like that. But one of the things which quite often comes up, and certainly in our conversations, is transport. If you're making it off site, you've got to transport it. Lorries are bad for the environment. We know that and we get that. Interestingly, if you look at the actual percentages of embodied carbon you can save on a balcony, if you design out one lorry load, you can save approximately 1%. If you design out one anchor on the scheme, you can probably cover a multitude of lorries because of the embodied carbon in one piece of an anchor going back into a building. And so there are transport efficiencies and loading onto lorries and so on, which make a big difference. But actually, the main thing really comes back to, if you're trying to reduce carbon, some of these embodied carbons and look at things in the true sense of value engineering, of actually looking at how you can design out some of these anchors, makes a difference from a cost point of view, makes a difference from an embodied carbon point of view. Materials are the biggest factor, certainly from a balcony point of view, and many of the components in the facade. So what steps need to be taken to ensure a building's carbon footprint is minimised for its whole life cycle? This kind of touched on what we just talked about, circular economies and so on, but Michael, have you got any more thoughts on this one?
Well, the whole life carbon, that's where embodied and operational come together, and that's exactly the right way, of framing things. I think there's always a risk of overcomplicating everything that you need to consider when you're designing, but for us to really make the right choice, be it on is it double glazing, triple glazing, argon filled or not, just narrowing in on a facade question, those the right optimal answer can't be resolved just by looking at the window. You actually need to zoom out a little bit so that you can consider the carbon over a 30 or 60 year period. So no, I think it's excellent that people are really thinking about that, and yeah, all sorts of slightly surprising conclusions will come out as we take that more holistic view.
As we've been mindful of our global audience on this one as well, obviously transport and also the integrity of the thermal efficiency and so on of the buildings will depend where it is in the world as well. Distances from North America and the nature of the cold climates, or if you're perhaps in Lebanon or somewhere with a warm climate, it's quite a different conversation, isn't it?
Yeah, absolutely.
You got any thoughts on this point, Toby?
So I'm a physicist, and one of the reasons I like physics is you can sort of go back to first principles and work out how things kind of go together and sort of work from the ground up. Yeah, one of the things about the embodied carbon or upfront carbon, whichever you want to call it, that turns me off a little bit is it's kind of an exercise in accounting. You can't, you got to do the numbers right, but the upshot of that is that when we've looked at this in my practice, you get very different numbers depending on exactly how you do that accounting and exactly which brand and type of mineral wool you choose. You can get wildly different answers, and so that's kind of a little bit of a frustration for me. Particularly when we get on site, we've done all our careful calculations, said, okay, yeah, we've done loads of work, and this is the right mineral to use, and that's better. We shouldn't go with PIR or whatever else. And then you turn up and do an inspection, and completely different type of mineral has gone in, and it's still maybe the right performance in terms of thermal conductivity or what have you, but the fact that it's brand Y rather than brand X can make a big difference to that, at least if you believe those numbers that we have access to, which is also another big question that I'm not sure about. So it's a bit of a minefield.
There is just as I was about to make a point about the one element, the believing the numbers is a big part of it. There is an element of playing around at the margins if it's coming down to whether or not a data sheet says it's 0.5 or 0.6. But there is a guiding principle, and it sort of comes down to if you were building in a location and that location had a vernacular for that architecture, that's grown up out of that particular area. It's used the stones locally, it's used those particular materials. And there's a degree of that. There is a degree of understanding your environment and what's gone before. And whilst I'm not advocating everyone lives in stone huts, there is a use the materials that are local. The same principle sort of applies to food and food miles, which is if you can use locally sourced produce, that's going to be better than flying something from halfway around the world. So there's a general understanding and level principle. The opposite end of that is, of course, that, I quite like monge too. And they don't grow it in this country, so therefore I'm going to have to import it. So that's this idea that everyone's got to start thinking differently. And maybe some of those thoughts are not particularly palatable as we sit today, but those are the thoughts we're going to have.
I know when we've spoken previously, you told me about an example of a product which could be sourced locally, but the reality is that it was being flown in from further afield. So it's not just the where the person is based, it's where the product is actually coming from, isn't it?
Yes. But just sort of touching on what both of you talked about, I think we still have the problem of a performance gap in terms of how the buildings are designed and predicted to perform, and in reality they do not. So probably having better tools or ways that we know that they're going to be close to what they're predicting. And I think we're trying to close that gap. And I think a lot of work has been done in that area, but more needs to be done.
Yeah, absolutely. And just we've got a few questions coming up about retrofitting. We'll come on to that in a second. One of the questions that's been asked is how useful is carbon offsetting? What's the role of it? Michael will start us off on this one.
So carbon offsetting has obviously been around for a long time, and I'm specifically skeptical about that step even being necessary. And I've only actually in the last couple of years come around to thinking that it's got an important place, because the communication around net zero in recent times is very much a sort of three-step process. So there's all of this focus on figuring out what your embodied carbon is, what your operational energy use is, and then having energy use intensity, the EUI targets. And so there's a clear sort of message that if you just don't worry about any of that and then offset, there's a big reputational risk there. You're going to look like you're greenwashing. So the fact that we're now focusing on bringing things down as a start point, really putting the effort in there, then yes, I think it's okay to be doing the offsetting as that final step.
I think the key is that it's the final step. You're right. It's the fact that this is, in some respects, it can be seen as paying someone else to wash your dirty laundry, but in others, it's actually in the hierarchy of who can afford to start thinking and doing and taking action. The people who are developing those products, buildings, whatever, then have the money to then make difference somewhere else within the world or within an area that isn't as advanced. So yes, the very good point is that it's not a panacea. It is an element of a triumvirate.
Just add really quickly, there is really good guidance out. The gold standard reports, for instance, or Oxford University have got out a guide that are setting out how to do offsetting coherently. And one of the things that's highlighted in those guides is that a lot of these offsetting mechanisms actually do have secondary value as well. So, for instance, the cook stove programs improve human health, reduce consumption of wood in areas where there's biodiversity issues as well. So these programs absolutely have positive impact, and not just on climate, on all of these other things as well, but they shouldn't be used as an excuse to not do the right thing in our home area of buildings and construction.
Certainly, it's a very valid point. It should be reduction first, then offsetting. And the sort of team schemes you're talking about there, one of our carbon consultants gave us some guidance on that. Is actually investing in some of those schemes which are reducing deforestation in the start is better than planting a tree.
Yeah.
Nothing against planting trees, but if you've got a mature tree and you're chopping it down, the amount of carbon that can take in a year is vastly different to a new sapling. And many of the deforestation or schemes stopping that sort of thing are re-educating people on how they can make money out of other things rather than deforestation. So there's lots of interesting and good work which goes on with some of those companies. But do you want to touch on that?
Yeah, I mean, there is usually a hierarchy that we need to follow in the construction industry. So we first of all need to be lean. So that is, we need to use less energy in the first instance. And then we need to be clean. So we need to supply energy efficiently. And then the third one is to be green, that is, use renewable energy. And it's only when you've done those three options that ideally you should then go on to the offsetting options. And I think there are some guidelines that clearly say, and I think one of them is the REBA Sustainable Guide that was issued over a year ago now, that I can't remember exactly, but they need to achieve it without the offsetting option. And so ideally it should be the last option. And we do appreciate that you could do so much, but still it would not be possible to completely sort of get that zero carbon, and then the last option should be offsetting, but not the first.
Yeah. So as Chris touched on some of those points, it is that whole view thing again, isn't it? Of making sure that you're not just using it as an excuse. There's a lot of other things which need to go ahead of it. Moving on to some of the questions which are coming in relation to some of the refurb projects. What's the role in actually using existing buildings? Toby, do you want to start with this one?
I think it's essential. It's kind of the reason I get up in the morning at the moment. I'm looking at, through my work, is at the moment mostly through, figuring out how to retrofit historic buildings without introducing moisture risk. So, slightly different to the sort of headline of today's event. But, it's the the simple sort of fact really is that the vast majority of buildings that we have here today are going to be present and occupied and in use in 2050. Hopefully by which time we're going to be zero carbon, and the stuff we're adding is by and large not adequate from a sustainability and energy point of view, but on the other hand it's actually a relatively small kind of proportion, and the elephant in the room really is the existing stock. So it's super important, I think.
Anyone else want to add to that?
Well, yeah, just to second that point, we can't just focus on new buildings. It's so critical, and also really pleased to hear that there are people like you focusing so much on this condensation and sort of humidity issue. I'm looking to renovate a bit of my own house, sort of 1895 Victorian terrace, classic sort of double brick, and pretty much all of the insulation options are fraught with risks on how they're installed. So we've got to tackle that head on, and some of it can obviously be done through technical work, but a lot of it is going to be in developing good products that can be affordable and easy for people to understand and install. Yeah. So
we're out of time now, I'm afraid, but we've got plenty more questions still. But perhaps if we have a takeaway from each of you, Michael, start us with.
Right. Well, so I'd say this facade performance on existing buildings is to conclude with the last point we were discussing. I think both from a thermal bridging perspective and this sort of insulation, but without causing condensation risk, is really top of my mind.
I think mine is sort of changing the mindset and for the industry to work together and collaborate and to support and nurture the sustainable technologies that exist today, because if we do use them and implement them, we can achieve the targets. But if we continue being risk averse, we are not going to get anywhere. And I think we've got to the point now that we've got to act. So let's collaborate, let's create an ecosystem and work together and see how we could accelerate that transition.
Yes.
I think from my point of view, it's understanding that as individuals we are all working within the construction industry. With our mindset change, we can all make a difference. Even the small changes are going to snowball and grow into the larger changes that are required. So it is incumbent on us as the current owners of that ability to change, to start that process and to make sure that it keeps going until the point where we hand the baton over to someone else.
I think Michael stole my thunder a little bit, so I was trying to think of something else to kind of contribute. But I think someone else in the last session actually was talking about education and the importance of that, and sort of as individuals across the supply chain, from designers, consultants, academics, right through to contractors, subcontractors, the guys putting the screws in and laying the bricks and all that kind of stuff. I think we all just we need more education and at different levels appropriate for different people to really question, to give ourselves the skills to question what we're doing and to make sure that we're pushing in the right direction in every sort of aspect of what we do. And if we don't, if we're not going in the right direction, then we're not going to get there.
I think my takeaway is be clear with what you're trying to achieve in your projects, be open-minded about how you achieve it as well, and also be aware of what might perhaps be hidden carbon costs. For instance, doing something on site might involve a lot of people traveling to site and might involve a lot of diesel vehicles ultimately, whereas some of those DFMA techniques may actually be quite impactful in that sort of regard. And also, one key takeaway from a balcony point of view is that actually you can save money by being more carbon friendly. So speak to us if you want to know how. Thank you very much for your time, everyone, and thank you for being on in Canada or joining remotely or around the UK.